Hello. Hi, good afternoon from Hong Kong. Good morning to Anne and also John from one's in Denmark and one's in Australia. So welcome everyone. Let me introduce today's lecture. I'm Henry Chan from the architecture program here at HKDI. So welcome everyone to the HKDI Master Lecture in autumn of 2021. Today's theme of the lecture is about architecture for the future. We have two very wonderful speakers with us today for this lecture and hope that we can inspire everyone to rethink the future of our cities. From the material scale of buildings to construction processes to the macro scale of cities and global environment, we hope that we can inspire students and people who join this lecture to start rethinking about our built environment. From 3 time zones, because like I said, Professor N is in Denmark, and also John is in Australia, in Melbourne. So also along with all our guests here, our students in Hong Kong, we're trying to sort of establish this international discussion. So we hope to bring you a global perspective in the exploration and innovation in architecture, and how are some of the possible methodologies and ideas that are possible or available to help solve some of the pressing global issues in today's cities. So after the 2 lectures today, we'll have a quick panel discussion. So all speakers will help to answers and maybe bring in more in-depth details about their perspectives on the topics. Please feel free to leave your questions in the message box in Zoom, and also we are on live on Facebook. We'll share your questions with our guests and hope we can generate some discussions. Also, our students here live in person, they can also raise their arms if they have any questions. So without further ado, let me introduce and welcome our first speaker, Professor N. Beim. Professor N. Beim is a full-time professor at the Royal Danish Academy of Fine Arts in Denmark, in Copenhagen. She's also the head of CINAR, C-I-N-A-R. I don't know if I'm pronouncing that as an acronym or as a word, but it's the Center for Industrialized Architecture. It serves to bridge the gap between the architectural education, construction industry, and architectural profession. Since 2014, she has co-chaired the graduate program specializing in settlement, ecology, and tectonics at KDK. From 2008 to 2010, she chaired the architectural committee for the Danish Arts Foundation, and since 2013, she has chaired the admission board for the Architectural Association in Denmark. So without further ado again, please welcome Professor N. Beim.
Well, thank you so much, and thank you for the very fine introduction. I'm very happy to be invited to this lecture and to share the ideas and the work we're doing at in our research center, and also together with our students, because we are just elaborating on some of these ideas that I'm going to present to you. But I understand it so that I'm now going to share my screen. Can you see it? Does it work?
Yeah.
Very good. Well, what you see here is just sitting. This is from an existing exhibition that is now running at our school. We have a large exhibition hall, and I'm going to return to this later in this lecture. I'm going to speak about what we call, or in our center, which we have been working on for some time, what we call radical tectonics within the realm or the framework of absolute sustainability. It seems a little bit sort of extreme in many ways, but actually it's just a way to try to get into the core issues of both tectonics, but also the aspects of sustainability. And I'll try to unfold this now in this lecture. But just for those of you who are not familiar or totally acquainted with the the concept of tectonics. I'll just briefly introduce it to you, and also talk about, and you probably also will see throughout the lecture why it's relevant. But as you may be knowledgeable about, the ancient theorist Vitruvius, who wrote the 10 books of architecture, one of the first theorists in architecture, defined the three concepts. I have a problem with my local screen here. Anyhow, venustas, utilitas, and firmitas, and that is the beauty, the utility, or the use, the functionality of buildings, and then the site or the technology of the building. And as such, tectonics is sort of like a subcategory of architecture of the larger context. And in that sense, we can define it as a smaller triangle that is concerned with the form, the technique, and the materials of which architecture is made. And of course, it sort of taps into the larger aspect also of beauty and the use of the building. So in that sense, it's all connected. Why is this now? One of our colleagues had sort of dug deeper into this concept of tectonics and defined what we call now the tectonic alphabet, which is the different ways by which you can actually work within the tectonic realm. And that is, of course, or in this sense, directly connected to building technology, which means the way that the different construction elements or the material connections are related. So it's, as you see here on the image, or the small diagrams to the right, it's different ways to sort of, in a very simple and very diagrammatic way, to relate the different materials or the different elements in structures. So as such, this is the way also that the tectonics in architecture defines the correlation between the overall architectural intention, the material properties, also the form principles, you could say the anatomy of the different elements, and also thereby the choice of the building technologies, and through this the structural rules which are present in construction. So altogether, it's about the specification and designing and joining of materials and the elements to form an architectural synthesis. And in that way, also as is said here, it holds an architectural ethics and an effective way to direct and control resources in construction. However, we are now looking into what we, at least from what we talk about here in Europe at the moment. We have the COP, that's a global issue, but we have the COP 26 going on right now in Glasgow, and we have different statements coming out from the meetings that it's very serious, and we now at a global level have to find solutions in which way we can solve the present problems that are also, you could define as an ecological crisis. It's not only a climate crisis, it's also an ecological crisis at a larger scale. And it also relates to the question of biodiversity, or lack of the biodiversity, resource scarcity, and of course the climate crisis we now see in different ways across the globe. And finally, we have problems with waste. Waste from construction industry is actually a very big problem, but waste at all levels, in particular, we also see the problem of plastic waste. However, these sort of overall question also calls for architectural answers. And why is that? In particular, when we look into the building and construction industry, we have a great responsibility to take part in this discussion and find solutions for societies. And if we look into the numbers, we are now responsible at this moment for 35% of the total energy consumption And also we have we're also responsible for 40% of the greenhouse gas emissions. Not the least, we also 40% of the total material consumption. And in the EU, we have the total waste of between 30 and 36%. At the political level, at least in Denmark, we have now decided, or our government have decided, that by 2030 we are going to have a reduction of 70% greenhouse gas emissions. However, that's just following the EU politics, in that sense that we in 2050 have to have 100% reduction, and these are not reductions as nothing at all. I mean, these are reductions in regard of the numbers we were or the emissions we had in 1990. As when we speak about absolute sustainability, and that's a part of a larger discussion in terms of the planetary boundaries. This is you could say it's a research field that has been defined by the Stockholm Institute and one of the main researchers, Rockström, who has sort of defined these different planetary boundaries from 9 primary aspects, also tapping into the critical aspects I was just mentioning before, as for biodiversity or polluting of the oceans, the air, and so forth. However, other researchers have looked into similar aspects as for the construction industry. And what does it mean when we have to build in terms of the absolute environmental sustainability? And they looked into to single family houses in Denmark. And in case we have to sort of fulfill these very, very strict requirements, it will mean that we have to reduce 89% of the harmful environmental effects of or effects of construction, and 80% of the greenhouse gas emissions from the energy consumption, and not the least, reduce the living space per person by 60%, which is severe numbers in regard of how we live today. So then, of course, that raises the question, if we are going to have less, you could say, living quality, or by which means do we have to sort of reach into that into these very reduced or ways of looking into how we built today and how we're going to build in the future. So what does this mean when we sort of dig deeper into that question of absolute sustainable architecture? By which means can we build? What sort of architecture do we look into? And from the tectonic aspect, as for, you could say, the material perspective, what sort of materials can we apply? So we sort of asked ourselves in the research center this question, and we also looked into it from a life cycle perspective, which means that we asked the question, how can we design architecture and build according to absolute sustainable principles? And what would the consequences be for the use of materials, the building techniques, and the tectonics and architecture? Looking into these very severe numbers of reduction, we very quickly realized the fact that it actually just left very few materials for us to apply. And we ended up with 3 main structural materials. That would be straw, wood, and clay. However, we also, being the center of industrialized architecture and having dealt with high-end industrialized analysis and research projects previous to this project, we also knew that we wanted to combine these sort of, you could say, simple materials with high-end industrialized thinking. So we wanted to apply these materials according to the present legislation, and also to the present industrial manufacturing systems and thinking. But before that, we actually sat down and wrote a manifesto for what we called the circular construction within the paradigm of absolute sustainable architecture. And we came up with, it's much longer than this, but I just took the short version, that we had to minimize the amount of materials and the number of different materials in the structure. And we wanted to use the uncontaminated materials, or not toxic materials, that should not be additionally treated. And we also wanted to use construction joints or assembly that could be disassembled. And we had to reduce the waste in production. What does this then mean? That means that we have to leave out materials that demand a great amount of non-renewable energy in the production and or had severe negative environmental impact. And that is mainly materials made from raw oil and synthetic materials. And that all together because we had to reduce the damaging effects on the health of humans, animals, and nature per se. We then, for this, in order to get deeper into this, we developed what we call the construction material pyramid, which is in this first version, is a small diagrammatic sort of system, you could say, that organizes the different materials according to their CO2 emissions. For this, we could sort of select materials, but also omit materials according to we wanted to sort of lower the emissions. So our primary take on this was actually with you could say a very narrow focus on the CO2 emissions, at least from the beginning. But that was just a way, sort of like you could say a design strategy in order to get deep into this to the question of the absolute sustainable solutions. So what did we do then? We sort of developed or discussed these strategies for radical tectonics, in which we wanted to use these pure materials. And as I mentioned, we also wanted to use the dimensions of the different construction elements dictated by industrial standards. And we wanted to have the least possible degree of processing of the materials and components, which meant we wanted to use the raw materials themselves or the components directly coming from industry. And then we had to consider these reversible joints, the way we wanted to construct the various wall elements. So it should be very simple assembly and simple construction details. And then, of course, it was all about this very low CO2 footprint. So, as mentioned, we use these standard components and very few custom-made adapted components or joints. And this was all made from this sort of like very clear and simple tectonic principles, which was sort of defined in the very beginning. So what did these radical tectonic experiments, what did they turn out to become? We built, as mentioned, or focused on 3 different material groups, and that the first one was wood in this case. So we wanted to make this wood prototype prefab module, sort of based on an industrialized concept. This we had to do, we made it by hand on site in our workshops at our school. But we tried to apply the sort of the procedures and the dimensions of the different elements given by the industry. So there was actually very, very few, say, craft-based procedures. And this could easily be done in a factory or a manufacturing plant. What was important was that these elements were joined with this sort of lock that could be locked and unlocked. And what we see between the elements is a cork plate that makes the joint sort of tight and flexible. So what we're investigating here or trying to do is actually mimicking the sort of industrialized products or elements, and at the same time sort of pushing the boundaries of this sort of thinking in terms of easy assembly. These elements could be carried by 1 or 2 persons and could be put up in a very short amount of time. So we sort of used all the different, you could say, dimensions of industrialized benefits combined with easy craft procedures. As for the second structure, that was a combination of unburned clay bricks combined with reused bricks, and for this we built it as you could say, as a homogeneous wall structure combined with burned block tile blocks that are this is a very common structural material particularly in Germany and the larger part of Europe. It has not been fully implemented in Denmark yet due to our very, very long tradition of using regular masonry blocks and bricks. However, it's a very, very highly efficient structural element, and it also has insulating properties. It's easy to build with, and it's also fairly cheap. So it's a highly industrialized product, and we wanted to combine this with these virgin materials such as unburned clay, and then the reused bricks. So it was a matter of how to combine these various elements in order to also benefit from the different material properties, where the unburned brick was on the inside wall and the reused brick was on the outside. So we came up with this, what we call it's sort of like a masonry hinge that makes it structurally efficient, and also sort of combines the wall in different ways. Then the last system was what was applied with using straw bales. And actually, while we have been working on this project, this is already a couple of years old, there has been now developed a fully industrialized product called EcoCocoon that is similar to this, a structural element that can be built, or similar actually to our wall, our wooden wall can be built in different sections, but also come as full wall elements. That's a fully industrialized product by now. So we're actually being, how do you say, the development in the construction industry is actually speeding up these years. So what we did at our school at this time was actually just the previous or early steps towards an idea of industrializing this sort of construction materials. And the straw bale, of course, is a very, you could say, a very simple waste product from the agricultural production, and this is applied together with a wooden frame and steel rods for structural for strengthening the structural for strengthening the structure. However, it was sort of this open framework that was later cladded with clay plaster, and that is primarily the question of fire protection, which has been an ongoing issue, and particularly with the biogene materials. So just to wrap up, for these 3 initial tests or experiments with what we call the radical tectonics within the absolute sustainable framework, we wanted to particularly emphasize the question of what we call the reversible joints, what we envision as tectonic motifs or ornaments. That also makes it easier to facilitate the maintenance, and it's also a more effortless reuse and recycling. But what is very important is actually that it separates the life cycle of the building from the life cycle of the materials, which means that you can actually just take out certain parts, but the building itself can maybe, or the structural core structural elements can be can be replaced depending on when they do need to be changed by new materials or altered due to the functional aspects. But altogether, it's also about this ethical awareness when we choose the materials and how it actually also taps into a larger cultural understanding of how we actually built in various parts of the world. And you could say these three experiments actually sort of is developed on the shoulders of a very sort of a deep understanding of the building culture, also within a Danish context, and how it also can be sort of developed into also industrialized thinking and products. So, just very briefly, just a quick presentation of the analysis we did on top of these experiments. That, as you see here, we have the different material spreads, which means that we have in the different structures you'd say we have sort of prioritized the materials very strictly in order to get these very low emissions. And of course, maybe the one we see in the center, which is you could say a critical one, because we have the insulating clay block that is also, or brick, that has also been of course has high emissions due to the manufacturing premises. It also shows that in the straw diagram that we have the straw bales as the main material, and in the wooden one we have the wood fiber insulation, which is not a structural material but the insulating material. So altogether, if we look across the three material types, we see that the insulating aspect is a very central dimension as for the amount of material that is applied. However, when we look at the greenhouse gas emission, or the CO2 emission, if you look at the diagrams to the left, this is how they are sort of situated or placed between what we have a very low emission to the left and the high to the right. When we look at it as for the kilos, the different materials are placed, you could say, probably very obviously at a high end. In particular, if you look at the center one with the clay brick or insulating block, we see it on the diagram to the left, that it has a high emission, but it's towards the center because it's a fairly light material. But when we look at the diagram to the right, it goes all the way up or to the top, because it then, because of the amount of material we have in the construction or in the walls, it then counts for a lot of the emissions. So what's interesting when we look at these diagrams is that the different materials sort of move up and down depending on how much material we're actually using in the various structures. So that is very important when we look into these aspects of the CO2 emissions and the impact. And as for life cycle analysis, we made this sort of very overall estimation of how many times, or how in you could say within the various time lapse, the different materials either could be replaced or would sort of get into either a technological circular reuse, or a more nature-based or biological circular system. And as when we look at the center one for the clay structure, it of course has a very sort of a long-term perspective as for the materials, whereas the straw and the wood have much shorter circles. However, they are also based on biogene materials that much more easily can get into the you could say the biological ecological systems. So in that sense, it's not these sort of diagrams and these sort of analysis have to be looked at very critically and also studied in detail in order to understand that it has very different impact depending on what sort of material and what sort of cycles, biological, ecological cycles they are part of. And finally, when we look into the overall global warming potential, as for the three structures, the brick wall, of course, I would say, turned out to be had high emissions, whereas the other two walls had low emissions. And these structures, of course, as you see in here, are just early indications of what sorts of materials, what sort of structures, and what sorts of tectonic strategies we can apply when we look into future use of materials, when we have to get into these severe or high reductions of the CO2 emissions. However, on the back of, or on the shoulders of all this work, we sort of kept on working or developing this, what we call the construction material pyramid, which has now become a digital tool. And I can share the website with you after this, or send it to your teachers. And as it works in a similar way as you saw the early edition of the pyramid. In that sense, you can choose the different materials and you can make your own little pyramid. In that sense, you just click on the various materials and you can define in the small calculator here at the bottom, define the amount or the kilos or the square meters, and you can also filter on the menu to the left if it's cubic meter or kilos, or what sorts of materials, if you're looking into insulating materials and so forth. So this has now become a very effective tool and has been spread out, at least amongst the educations within architecture, engineering, and construction in Denmark, and it has also now been being applied in Holland. So in that sense, not knowing that what we started out just 4 years ago has now become a new way of talking about materials in a much more, you could say, critical but also observant approach to the use of materials. So how do we then continue working or researching into these radical tectonics? We have then, on you could say the second step in regard of this, looked into the biogene materials and how we can enforce or enhance the use of biogene materials in structures. And we have now looked into facades, what we call with CO2 neutral fireproofing. And these facades are thatched facades. And the fireproofing is clay. And this project we're doing with it together with the Danish Fire Security Institute and two thatchers and a small entrepreneur that is working with clay in different sorts of structural combinations. What we see here is actually that we have, if we look back into history, we see that certain roof structures in Denmark have been applying clay as the top, as you could say, the finishing of the roof, where the clay sort of runs down over the surface, and in that sense, you could say fire improves or covers the surface in that sense that it cannot burn that easily. But this project is both looking back into history and seeing or investigating what sort of historical experience and knowledge can we draw on, and how can we actually translate that into contemporary or present day construction industry. So we have been looking into these thatched facades in that sense that we wanted to apply different sorts of clay materials and lime in combination to impregnate the different surfaces in order to test and select a particular or the best performing structural combination. And this is done in the Institute of Fire and Security, and using also their sort of laboratory equipment and their test facilities. We started out with these 14 different combinations of materials and the way they're applied on the structural elements. And they were tested in the standard procedures, and we came out with these similar 14 tests that had been had very different performance. But what we see is you have to pay attention to number 4 from the left, and actually the final one and the third final one on the right, that those 3 were actually the ones that performed very well, having clay put on the surface or in between the straws themselves. On the basis of this, we then selected these particular ways of applying the clay and the thatched surface together, and we made these two major larger elements that were going to be tested for their performance. We now have these 3 elements that were the one you see, the 3 standing to the right. The one of the 3, which is the far left, is the one without any sort of clay impregnation. So that's sort of the baseline on which we sort of test the other 2. The one you see to the very right is having these clay plates in between. It actually makes this sort of what we call a fire stop, which makes the fire sort of run over the surface in a different pattern that also hinders the fire development. So then they're tested for about half an hour, and they actually they performed extremely well. Actually. Similar to highly efficient materials that they usually compare with. So what we wanted to do is actually, as part of this project, was also to present it as, you could say, a surface or a cladding material or a cladding technique added on to this highly low, high performance, low emission construction, such as the straw wall or the straw bale wall. So we built this structure that is now presenting, you could say, the combination of the initial research with now this the second step, where we sort of want to develop cladding or facade surfaces that can be added to these sort of structures. So this is now sitting in our exhibition hall, and it's exhibited until the 4th of February. And we now also have a lot of different responses to it. And it happens that the ministry or the authorities that are taking care of our listed buildings in Denmark are now very interested in this research, because they want to have recommendations for the listed building, that when they alter or how do you say, change the construction for various reasons, they want to do it with materials and procedures that are similar to how they were built originally, and not sort of adding contemporary artificial synthetic materials into these sort of old sort of structures. So this project somehow already has have had an impact, or will have an impact on the on yeah, at least this is from, you could say, older buildings, but we also hope that this can have an effect on more present day understanding and present day structures. Anyhow, we also try to test this or put this structure into the our construction material pyramid, and compare it with a regular housing, one family housing a structure that is made, like 80% of the Danish housing industry is single family housing. And what we see here to the left is a structure made of light concrete in the interior wall, and in mineral insulation, and then bricks on the front. And on the one to the right, we see the prefabricated straw element in the interior with a thatched surface or cladding. And very obviously, the two pyramids or the two structures are performing very, very different in the pyramid, and we see that the structure to the left is a very high emission structure, and the materials there are not. If we look into the 17% less perspective, it's not the way to go, and we have to sort of push ourselves towards the way of thinking and the material catalog as we see to the right. So just to wrap up, where to get started when we look into the radical tectonics for absolute sustainable architecture, we could say it's all about ecologies. All these things, all these materials, the way we construct, the way we think is connected. So it's also an ethical understanding of material resources. Where do we get them from? Where do we harvest them? Are they local? Are they transported from afar? And how do we actually also share or apply these various resources in ways that are responsible in terms of our you could say our CO2 footprint, but also our environmental environmental issues. So it's about, you could also say it's about choosing an overall strategy, and I can recommend you to write an ambitious architectural manifesto. At least it helped us in the very beginning. And then, of course, it's a matter of defining the principles to specify the design rules and fabrication methods in this case, but in particular the design rules that are sort of forming the basis for this new way of thinking to come forth. So this was the words. I hope I'm not too much over time, but thank you.
Thank you very much. Thank you for Professor Beim's very insightful sharing. Obviously, this day and age, we're all dealing with global climate issues, and to be so insightful with your research and innovation in the tectonic systems and construction methods, I think we can all learn and maybe kickstart these kinds of conversations everywhere globally, and see what we can do to improve our built environment and our cities. So we'll come back to you later when we open the floor for the panel discussion. But for now, we'll shift the discussion, this discussion about architecture for the future to a city scale. So next we have Professor John Doyle from RMIT to present his lecture about super tight. So Dr. Doyle is a registered architect, also the head of Master of Architecture at RMIT. He's been working on a lot of projects internationally in Australia and abroad in detailed design, delivering award-winning projects around the world. He's a founding partner of NAU and was a project architect for Lab Architecture Studio and Toyo Ito Associates, where he worked on the delivery of highly complex international commercial projects. Dr. Doyle specializes in the delivery of high-impact public realm projects that make the most limited budgets and extreme timeframes. He is the head of the master's program at RMIT, as I said, and leads several research teams investigating the future design of cities in Asia and Australia. So without further ado, please, I pass the mic to you, Dr. Doyle. Thank you.
Thank you. It's nice to see people in a room together. It's a bit rare these days. I'm going to jump straight into it and share my screen because I know there's always the potential for that to go wrong. How's that? Is that sharing my?
Yeah.
Are you getting? Yep.
Yeah, we can see your PowerPoint. Yep.
Okay. Now let's see if that. Okay. Full. Is that full screen?
Yes.
Great. All right. Well, yeah. So thank you for having me. It's really a pleasure to speak to people in Hong Kong. I've spent a lot of time in Hong Kong, and it's a place that I have a lot of love for. So thank you. The lecture is called Super Tight, and I'm talking about the super tight city, and that is a concept. I'd just like to acknowledge that a lot of the work that I'm showing you today is the work of many people, but specifically my partner, Graham Christ, who works with me at RMIT. So I just want to make sure that he's acknowledged in this because this is a co-authored effort. So more than half the world lives in cities. More than half of the world's population lives in Asia, and more than half of the world's megacities are in Asia. So Asian megacities are the key to new ways of being densely urbanized. They're the byproduct of unprecedented metropolitan convergence and provide insights into the emergence of new urbanisms, new architectures, and new models for living and making culture. So the super tight, the term super tight, refers to small, intense, robust and hyper-condensed spaces that emerge from extreme levels of urban density, such as the image you can see on the screen here. Tightness is a consequence of density, but it's more than density. Tightness captures social, economic and cultural practices that have developed in cities as a response to their rapid growth and consolidation. To be tight is to be small and perhaps constrained, but also to be open to the economies of new economies and social intimacies from being close. Tightness is the reconciliation with and an adaptation of social behaviours in hyperdense urban environments. So this figure changes every time somebody talks about it, but however which way you consider it, cities produce a large percentage of the world's global greenhouse gases, as much as 60 to 70%, depending on the data. So and Professor Anne Beim just described and very succinctly set up, one of the key points that I also noticed in her lecture was really that the idea that a reduction in footprint and specifically designing small, compact footprint cities is one of the single greatest impacts that architects, planners and developers, city makers can make on climate change. So this concept of density is something which is obviously highly politicized, fraught and culturally specific. In some cases, density has reached an extreme that is problematic and benefits a very small group of people over the many. Most notably, an example that you might all be familiar with, which is the subdivided apartments of Hong Kong. But for the majority, for much of the world, the question of density goes to the other point, and density becomes a battleground of ideas in terms of how we tighten up and how we kind of implement density where there is none. So the context that I'm coming from here in Melbourne is of one of the most loosely, or the opposite, undensely settled cities in the world. Melbourne does have pockets of very high density, comparatively speaking, particularly in the city and in the suburbs, but the majority of its city and many cities in Australia and North America are incredibly low density in terms of their settlement. So this project is in part directed at into this space and trying to learn and sort of create strategies for how cities as a whole can be more closely settled. So the questions we ask are, how do we create good density? What is good density? How do we change the narrative around density? And how do we make density desirable? So as I said before, tightness is not density. Tightness is not size. It's about the relationship between things. We worked on this project with Yoshi Tsukamoto from Atelier Bow Wow, and one of the ways that he described it was that tightness was about, could be an analogous to the idea of how we might have a tight relationship with a person, or as an architect, we might have a tight relationship with a skillful contractor or a carpenter. And so in those cases, we say we've got a tight relationship, and cities and buildings are the same. Like, it's possible, in order for a building or a city to be tight, it needs to make the best use of the resources that it has available to it, and waste nothing. It's very possible to live poorly and loosely in a dense city, and equally, it's very possible to live tightly and well in a kind of rural setting or a sparse context. So to test these ideas out, we set up and delivered an exhibition that sort of explored the idea. The exhibition was held in 2019 from July to September in the Design Hub Gallery at RMIT University. So this is Melbourne's only purpose-built design gallery. And so the exhibition was formed of a series of large-scale or 1:1 installations, which allowed us to really kind of explore and test the idea of tightness as a concept, its relationship to density and human occupation. The exhibition was aimed for a sort of broad audience, not just architects and designers and planners, but also like a public audience. The exhibition formed part of the 2019 Open House Melbourne Architecture Festival, and was the opening event for that. So we were very much interested in how design and exhibition design could be used as a didactic tool to kind of illustrate and kind of provide experiences of this concept of tightness and the consequences of that, not only for a disciplinary audience, but also for the public. And so the exhibition was made up of a series of parts. I don't know if you can see my cursor, but in the main gallery, we had what we called the Tight Cinema, which was a series of large-scale projections, a very small bar that we called the Tight Bar, the Tight Hem, which was a laneway that ran along one side of the main space, and the Tight Laneway, or the Tight Gallery, which was in a secondary space to the side. So the Tight Cinema, as you can see here, was a huge series of projections of work contributed by architects, designers, and artists and sort of thinkers from throughout Asia. So we had video and still work contributed from Japan, Korea, China, a number of contributions from Hong Kong, from Vietnam, Singapore, and Malaysia. And all of these films considered the occupation and kind of design of cities in different ways. The Tight Hem, hem is a Vietnamese word which means, it means effectively laneway, or a type of laneway, which was became a sort of a gallery or secondary gallery space and event programmed space, exhibition space. The Tight Bar, which was a kind of miniaturized lecture theatre and kind of discussion space, and this is Tight Laneway. So the Tight Laneway Tight Gallery played a host to a series of 1:1 large-scale drawings of scenes depicting scenes of, I guess, tight inhabitation in Tokyo. They were produced by the Taishin Shiozaki Laboratory from Tokyo Institute of Technology. So one of the key ideas of this exhibition, as I said earlier, was exploring the concept of the 1:1. So it's one thing to discuss density through sort of numerical measures or kind of economic models, which is often, how planners and economists discuss the kind of design of cities. But as architects, we wanted to know what and understand what the consequences of density and therefore tightness are at the scale of human experience. And so I guess the contention behind this is to understand the tight city, you have to kind of, be within it in some ways. And so everything we did in this exhibition, from the kind of the development of these installations to the kind of projection of drawings and kind of film on the wall, was about kind of giving a larger than life, or as large as life experience of this. So the drawings that were hung on in the tight gallery were effectively drawn at 1:1, and the installations that we built were kind of really directly modeled from observations and experiences that we've had living in different cities throughout the region. So the tight hem, which occupied the main gallery, was modeled very directly on as a kind of study on an actual laneway in I think District 1 in Ho Chi Minh City in Vietnam. And so what we did in order to sort of transpose this this sort of bit of urban fabric that we identified as being kind of interesting, was to undertake a process of abstraction and kind of remodeling. The intention of this was that we didn't want to just relocate this or kind of represent this space into the gallery as a sort of very particular singular one-off space in a city from another part of the world, but rather to abstract its kind of dimensional qualities, its spatial organization, its tectonics to a degree, so that there was something transferable and kind of learnable and kind of could potentially be applied to other spaces in sort of future cities or future architectures. And so we initially modeled this space very, very directly, sort of applying all of the kind of furniture, downpipes, windows, doors, and everything like that. And then sort of after that undertook a process of abstraction in which we stripped this back to a kind of very abstract sense of the kind of spatiality, the proportion, and the kind of extents of the existing, being the kind of the key factors which influence its potential performance. And I'll come back to that in a second. The tight bar was modeled directly, again, from a bar that is very well known in Tokyo, which is also called the tight bar. And perhaps the kind of beginning, one of the key inspirations for the project as a whole. The tight bar is a bar in Shibuya in Tokyo, which is a kind of famous, particularly for architects, as a place to come together and have debates and discussions. And I used to go there a lot when I was a student in Japan. And so again, there's a process of transposition and translation. What from the urban environment can we learn and what can we transfer? Obviously, when we take a bar out of a particular context in a different city, we strip it away of all the kind of rules and regulations which perhaps like governed it in its first place. So we had to remodel the stair so that it complied with Australian standards. It had to have a handrail, tactile indicators. In the context of the gallery, it couldn't have a top because the fire regulations say that the sprinklers from above have to spray into the galleries, into the bar space. But what it did do was create a kind of very small space which had a limited capacity to hold people. And when those people were together, they were oriented around a bar, and a very particular sort of group dynamic could emerge. And so the second part of the exhibition as a kind of research project was the process of performing these spaces, using these kind of installations and kind of bits of work and artworks which have been contributed as kind of like a part of a participatory event in kind of experimenting with the kind of experience of tightness in the urban environment. And so, the tight gallery was really only understandable as a kind of space that you kind of put the body up against. We tightened it so that the viewers would be almost kind of within sort of, immediate sort of contact of the very large drawings. You can't see them, they're blurry on the left. So that you understand the experience of density and experience of tightness in those cities at the scale of your own body. The tight bar became what we call the world's smallest lecture theatre. So we invited a series of architects and thinkers and academics from around the world who happened to be coming through Melbourne, or we brought to give talks and discussions in this bar, and basically the kind of interesting thing about that is the discussions became incredibly intimate and very kind of very fluid, because there was only a small number of people that could fit into there. So anyone who came and could fit into the bar was welcome to participate. But equally, there was a spillover out into the gallery, so people could see it through the window. They could stand in the laneway outside in very much the same way you do in the real type bar, and kind of be like a voyeur, or kind of watch on to the discussion. The hem became a kind of an overflow space, or a kind of ad hoc space for the gallery. So it was the overflow for the bar talks in the bar, but it also became a pin-up space for students and like informal kind of events. And that's very much similar to the way that the real hems of Vietnam work. The windows that orient onto the bar come from domestic or kind of semi-commercial spaces, which sort of often reuse or utilize the hem space as kind of an overflow or kind of like auxiliary space for the activities of everyday life and kind of commerce. We use the gallery, the hem, to hang some works by Atelier Bow Wow, not at 1:1, unfortunately, but I think 1:5 or 2, along with some comments on the exhibition from Yoshi. We hosted a workshop by Drawing Architecture Studio from Beijing, who came down and used the gallery, the hem space, to create a mural, a huge drawing, unpacking and understanding the kind of the activity or the life of Melbourne. And so this live research project allowed us to develop 6 observations about the tight city. What I'll do is I'll run through these observations quickly now, and then talk a little bit more at length about a new project that we're kind of developed or starting to work through that's come out of these observations. So the first thing that we observed was that in order for a city to be tight, it must allow for overlapping and sharing, both at the architectural scale, but also at the urban scale. So one of the main contributions that Shiozaki Lab contributed through their drawings in sort of observing the relation, what perhaps the difference between density and tightness might be, is the idea that cities don't operate on, there is not a 1:1 relationship in terms of program or function and space, urban space in cities. That through time, cities allow for kind of different activities to take place at different times and at different intensities. Perhaps the most obvious example of that, and the example that's illustrated in the big drawing that I just showed you of the cherry blossom viewing, is the parks of Tokyo, which became the scene for this drawing. And they can be variously very, very empty and operate as kind of the lungs of the city at a certain time, but at other times they become incredibly dense, like the densest part of the city. And the example that Shiozaki Lab used of this is the cherry blossom season, where for a very short period of time, at a very particular time of the year, almost everyone in the city empties out into the parks to sit under the trees and to experience the cherry blossoms, but also to have a big party. And I guess the extension of this idea and the analysis as we sort of jump into architecture is, is like a move away or a critique of the 1:1 relationship between the planning of a building and a particular use. So we have to move towards a model whereby buildings also, as well as cities, allow for multiple uses to take place within the same footprint and within the same volume. And the example we often cite of this is Atelier Bow Wow and Yoshi's office, which is kind of a hybridized work like office and house. Atelier Bow Wow is not a small practice, which allows these kind of functions to blur and reuse spaces variously depending on timescales across a kind of very fluid section. And the reuse of footprints is a way for us to dramatically collapse the footprint of the city and perhaps tighten it up without necessarily having to go to like the kinds of extreme levels of personal space loss that we described in some of those earlier images. The second idea is the notion of what we call rascachismo and adjustment. Rascachismo is a Mexican-American expression that was introduced to us by Archie Pizzini, who is a Mexican-American architect currently practicing in Ho Chi Minh City in Vietnam. And rascachismo describes the notion of a radical adjustment, or the ability to make do or like remake your world using very basic elements ingeniously. And so what you see here is one of his photos, which is of a kind of a vending stand, which has been built out of a series of kind of discarded elements and also a substation or a little electrical box there. And so our contention is that rather than kind of planning the city and kind of like, you know, which tends to kind of allow for more space than we will ever necessarily need, we should be working on a kind of ad hoc, informal basis, adjusting only as we need and for what we need at a particular time, and allowing the flexibility and informality to do that. And perhaps a good example of that is the way that Tokyo, over the last 70 years since the Second World War, has incrementally metabolized itself at different rates and in different ways to allow for sort of different sort of new generations of buildings and footprints to exist through a cocktail of circumstances, but in a very kind of interesting way. Through the work, we identified that that there is a particular formal dimension and a textural quality of tightness, a kind of a language that we could identify and perhaps deploy as architects in the design of tight architectures and tight cities. The first of those is the notion of what we call the no-edit city, which leads on from that idea of like adjustment and rascachismo. And we describe the no-edit city as one in which we don't knock down, we don't kind of work from kind of a tabula rasa or a greenfield condition, but we constantly accrete and add. So buildings are laminated onto one another and we add on as we go. This work contributed to us by New Office Works, which is a Hong Kong practice, sort of also contributed to that idea that the city, the tight city is obviously one which is produced through layers of incremental growth and change through time. The other idea about kind of a formal tightness or kind of a formal system for designing tight spaces is counterintuitively or paradoxically the notion of a kind of total looseness. And the idea here is that as a space becomes more and more kind of dense or more tight and more tightly occupied or a smaller footprint, the more you need to eliminate the kind of the specificity or the subdivision of the plan. The example we use here is of a bingo house, which was a video contributed by Toru Horiguchi from Osaka, looking at a standing bar in Osaka, where it's just a room with nothing but a few tables, a kind of a movable bar and movable serving area and nothing else. And that it might seem like a silly idea or a basic idea, but the idea that like a space has no fixed elements, what allows for a kind of totally fluid and totally kind of a highly kind of intensified occupation for certain parts of the day, and then sort of for it to be packed up at night. And perhaps like an architectural example of that again is again the work of Atelier Bow-Wow, where as the footprint of a building shrinks down to almost nothing, it becomes necessary to achieve a kind of fluidity and looseness through the section to allow for a kind of spatial differentiation and kind of different modes of occupation. The fourth point is the notion that that there are two different ways we can think about tightness or density. One is that density is kind of a byproduct of forces beyond our control, and that there might be outcomes from density which are undesirable. But the other is that there are aspects of density and aspects of tightness which are incredibly desirable and for which humans continually return and gravitate. And so, like, as we sort of emerge from this COVID-19 pandemic, we sort of think about these kinds of experiences in cities, experiences of closeness, of close exchange, and kind of congestion, the culture of congestion, for which cities, you know, are kind of the basis on which cities have emerged. There are sort of cultural practices that are kind of associated with living tightly together and closely, which are to be valued and perhaps probably kind of celebrated if we are to kind of shrink the footprints of our cities. There are many examples of incredibly dense cities, which are kind of also associated with high levels of livability. And so perhaps what we should task ourselves with as architects and urbanists is not necessarily the control of density or the kind of, the limitation of it, but the creation of density or the kind of facilitation of the types of densities that we would like to see, and the generation of the kinds of spaces that allow for that. And so one of the things that we've been looking at is, in effect, the miniaturization of the city. How do we shrink down things like roads? How do we shrink down production spaces and bring them closer to us? How do we kind of bring the aspects of working and kind of office environments closer together so that they, the bits of those that are good really remain, and the bits that we don't want get sort of set aside or compressed. We noticed that there was a relationship between the concept of tightness and culture. The sociologist of socio-psychologist Michel Gelfand talks about tight and loose cultures in terms of sociology and kind of psychology around the world. And we sort of asked ourselves, do you need to be in a tight culture, in Gelfand's definition, to be able to generate a tight city? And can we live loose in a tight city? And what we sort of discovered, and sort of, the jury is sort of out on this one, that, there are examples of what Gelfand describes as extremely tight cultures, a tight culture being one which is very sort of homogenous and kind of adheres very closely to agreed social norms. And an example of that might be Tokyo or Japan, where there's a high degree of ethnic homogeneity, but also a high capacity to tolerate density and to kind of live closely together. Counterintuitively, we might think of cities like Ho Chi Minh City, which has been described as Gelfand as having a very loose culture, a very kind of high capacity tolerance for difference and kind of the breaking of rules, I guess, but at the same time incredibly dense and a high capacity to kind of live closely together. So it's interesting that there is no kind of indexical relationship between culture and city, but there are some places which seem to do it and some places that don't. The last point that I wanted to kind of touch on, and I'm running out of time, so I'll fly through it really, really quickly, is that in producing this exhibition, we had a lot of contributions from particularly landscape architects and kind of territorial thinkers who pointed out that we can't just look at cities and think about density and and sort of ignore the broader consequences of density. Cities they don't stop at their borders in terms of their impact. And we sort of live in a planetary network, which is totally interlinked. So when we talk about cities and density, these kinds of images come to mind. We think about the center of kind of highly populated dense cities, such as Central in Hong Kong. And, a lot of the efforts of architects and designers and urbanists is poured into kind of this idea about density. How do we pack things in more closely together? How do we make it work as a kind of spatial problem? But in actuality, one of the major issues to do with any city or densities is the idea is the sort of broader global footprint and hinterland of our planet, which is required to support them. That doesn't really make a difference whether you're generally speaking, tight cities are kind of more efficient than not tight cities, but they still, what you tend to find is that, there is a kind of out of sight, out of mind kind of dimension to the very, very tight city, because as the city compresses, as productive space is pushed out of it, there is the capacity to kind of forget about all of the kind of things that are required in order to make a city operate. And so the kinds of spaces that exist outside of the cities but power them have huge consequences for kind of planetary sustainability. So obviously things like power generation. And so I guess we can't think about cities like spaces like this without thinking about spaces like like that. An example of this that came up through the exhibition was Singapore. Singapore is one of the most dependent cities in the world in terms of its food supply. A huge percentage of the food that and kind of produce that Singapore consumes comes from the Johor Peninsula and across the straits in Malaysia. And one of the films that was contributed to the exhibition was by some landscape architects based in Australia and Singapore, and they cast into sharp relief the relationship between spaces of consumption, which you see on the left in Singapore, and the planetary hinterlands, and specifically in Johor here, which support them. And so this gave rise to a new project that we're currently working on called Making Tight, which is really looking at how we fold these spaces of production into densely planned, densely settled urban environments. And the idea that it's not enough to simply live closely, but we have to live and produce closely together. And so we put together a small exhibition on this. We collaborated with some architects from Brisbane who looked at how the domestic space, the house, might become a site of cultural production. They sort of use their own house as an example, which is not only a kind of living space, but an office and also a place host to events, symposia and kind of teaching activities. We collaborated with some young architects from Seoul called Proud, who were looking at Songwoo in which is a district of Seoul, which used to be a kind of office district and now has been refit to become a kind of making space in the kind of digital technology economy, using kind of prosthetic additions to the urban environment such as these. And we've also been undertaking a series of projects specifically looking at how food production might become a part of our cities. We launched this a few years ago with a kind of, and this will be close to home, with a specific project looking at Hong Kong. And as you know, Hong Kong is has one of the highest rates of food imports in the world. I think it's somewhere around 95%, between 90 and 95% of the food comes from internationally. So the question we've been asking ourselves is, what if all of our food is grown within the city limits? In Hong Kong, we looked at this as a kind of adaptive reuse exercise, particularly considering the density of the footprint. And we looked at this site in Kowloon, which I believe is now demolished, as a potential kind of like a site that we could reuse and adapt. And so the scenario we set up for this was, looking to the future when perhaps car parking has become redundant from the emergence of driverless cars. And we looked at the adaptation of this this parking structure, which you guys probably would have known, to become the host to high density growing aeroponic growing systems. Aeroponic growing, or kind of aeroponic agriculture, uses less water, no pesticides, and is about 22 times more efficient than traditional agriculture, and can be sort of packed together densely in kind of interior environments, and largely requires no space to service it. And so what we worked out was, from that kind of arrangement that I just showed you, we could, this footprint could produce the equivalent of about 700,000 square meters of normal productive agricultural land. And if we extend that to every unused car space, every sort of car space in Hong Kong, that produces, it's the equivalent of this much agricultural land, which is roughly equivalent to about the amount of leafy greens that is consumed daily in Hong Kong. And so I've got to finish up, but what that sort of sets up is a really interesting kind of hypothesis or kind of future vision of the city, where buildings and kind of the urban environment is potentially not only for people, but we in a future in which we might need to consider how the productive components and food production specifically might be factored into the kind of mix of buildings in our cities. And so really quickly, we looked at bringing that back to Melbourne, what that would mean at a kind of an urban scale and at an architectural typological scale. Melbourne has a very large footprint, a very large ecological footprint, but because the city is so dispersed, as I said earlier, there is a greater potential for this to be kind of re-injected back into the metropolitan boundary. And so using GIS, we did an analysis of existing agricultural, redundant car parking and brownfield sites in the city, and worked out that at a reasonable scale of density, it would be possible to accommodate all of the food production required for the city within a 120-kilometre radius, which is approximately an hour's drive. When we produced a series of test sites throughout that municipal boundary, looking at what it would mean at an architectural or kind of, urban precinct scale to begin to house these activities inside of buildings. And so we looked at that at the sort of outer suburban site. We looked at that at a kind of inner urban brownfield industrial site that's been regenerated. We looked at that as a kind of the intensification of the urban periphery and an existing agricultural site. And lastly, and probably most radically, we looked at the prospect of repurposing the kind of envelopes of our like high density city to become kind of a space that is productive and in support of the consumptive landscape of Melbourne. So that's it from me. Thank you. We are publishing a book on some of this material early next year, so please keep an eye out. And we look forward to I look forward to the conversation.
Thank you, Dr. Doyle. Very insightful and fascinating sharing. Obviously, in Hong Kong, we deal with this kind of density and tightness all the time, but I think we all often look past, these issues from whether it's a top-down kind of perspective on looking at our cities, or whether it's from, a building scale kind of design perspective. So maybe now it's the time where we open up the floor for discussions. We've actually been receiving some questions online, so I'll read them and then maybe we can just have a discussion, a few questions. So the first question is actually quite a generic question. What advice would you give for young architects? So in the context of the two lectures, feel free to share your thoughts. It's quite broad.
Well, of course it depends on what is this young architect looking into? I mean, are you looking into your coming career, or are you looking into specific aspects or problems that are present in a particular project? Whatever. At least from the perspective or the position, you could say, from where my lecture was presented. We at our research group is very much concerned about the whole question about materials they're used in construction and architecture, and where do the resources come from. So my primary advice would be, from the perspective of, if you're looking into an architectural project, think about the materials. It's a very, very sort of fundamental part of architecture. Also, when we speak about the urban development, as Dr. John Doyle just presented, we do have those mega cities all over the world. They're going to, I believe, exist also in the future. However, when we do build new structures and plan new cities, we have to think about the materials which I just presented. How can we implement them in a larger amount, or at least we do know when we build above 3 stories, we are automatically applying steel and concrete, and that we cannot do in the future. So we have to find new ways of constructing. We have to find new ways of planning our cities in order to build in new ways. So I would say, think about the materials. That would be my recommendation.
Thank you. Dr. Doyle?
I think that's a great suggestion. And I agree completely with that, that advice. I would also, coming from a slightly different perspective, say that I think you need to be radical, because there's plenty of people, and both these lectures have been radical in the sense that they are kind of rethinking things from, or attempting to, and certainly in my case, rethinking things from the bottom up. So there's just not enough time for kind of to waste in this, and there will be plenty of people who will tell you why you can't do things. But I think that there is a space for, and there's also plenty of people who can draw drawings. There is not enough people who are prepared to kind of rethink things and to kind of offer solutions. So I think there's always the space for that. And yeah, and I think in order to be radical, the key thing is to have a really great ideas, because ideas are sticky, and they sort of like they allow you to kind of sidestep hurdles. So if you have a kind of an idea and a philosophy, a manifesto, as Professor Beim described, I think it gives you more resilience as a practitioner, because lots of things will kind of knock you back. But if there's something you believe in and something that you think is kind of worthwhile, it will, it'll sort of scaffold you against those difficulties.
Great advice. Resilience against the world is actually something that we all need to kind of be quite strong and confident about. We have another question for Professor Beim. Thank you for your insight. In the context of Hong Kong, where most things are mostly about efficiencies and profitability, it's oftentimes difficult to bring innovation to the construction methodologies to mitigate or improve environmental problems. Many cities, countries face similar problems. How would you suggest the construction industry help mitigate or mediate and start this discussion? Do you believe these kinds of innovations can work with the support and implementation from top down only?
It was a very long question. As far as I understand it, it's somewhat similar to at least the answers we just came up with, but I think to answer it in a different way, or come up with an example, researchers from CNAC were invited by Prime Minister Modi, responsible for urban planning and the construction industry just 2 years ago. And first we thought it was a misunderstanding that we were invited for this larger conference about how to develop the construction industry in India from an industrial point of view. But it was a proper invitation, and our delegate who presented the work, which I also presented today, within this larger context of other interesting perspectives, she came back and she said, well, when we propose materials such as clay and straw and wood, it's problematic from the perspective that like in India, they have prohibited cutting down trees, or the forests have now been protected because there's so little of it, and it cannot be applied for construction. And for that reason, they have now looked into a series of hybrid structural solutions that are lightweight, composite, combine different sort of structural principles in order to, you could say, enhance the structural properties. And that was very, very interesting for me to hear about, because we, from a European perspective, may think that, well, now we just develop wood architecture, or wood, the wood applied in construction. I mean, by all means and all over, and that may of course not be possible, because we don't have, you could say, supplies or forests enough to do that. I mean, to do the change overnight. And also we have to look into all the you could say all the legislation and rules and regulations that are also more or less prohibiting it today to happen, in particularly the fire restrictions and so forth. So how do we actually how do we get to do this in a clever way? I do believe that it's, as you also mentioned, John, that it's a bottom up, but I also believe that it can be done from the top down, in that sense that many of the manufacturing industries in construction, they do have they do have the knowledge, they do also have the technologies, that they can do like small incremental steps towards the application of these materials as I presented and others similar, to sort of integrate it into their existing procedures, such as the concrete industry that are now today, how do you say, casting concrete in ways and with procedures and techniques that easily, or maybe not easily, but at least could be considered to apply maybe unburned clay material similar, because many of the procedures are similar, but the material is different. And of course, it does need new education and knowledge and research and so forth. But at the same time, it's not. I mean, it's not impossible. So, yeah, in order to try to sum up the answer of this question, I would think that it is possible for the existing industries to actually reach out and apply these or sort of integrate these new sorts of materials and the knowledge connected to it. And also think, as for the construction industry, I mean, just 50, 70 years ago, at least in Europe, we built by these materials and by these sort of structural principles. So it's not, I mean, we don't have to reinvent the world. We just have to look into what did we actually just do just a few years ago, and how can we build on top of that knowledge, and also look into the existing building culture to see how that can actually, how do you say, benefit in terms of improving the you could say the downtrack which we are actually sort of yes, moving down right now. So it's, yeah, I'm not how do you say, I still believe that there's ways to do this in a clever way.
Yeah, I think, sorry, I'm just kind of reading another question which follows what you just talked about. Having these kinds of discussions, is it important to engage the communities? Because I guess this applies to both speakers. When you're looking at cities at a sort of human scale, and also at the construction methodologies and construction processes, it's important to really think about how it benefits the end users. So the question here is actually asking, how do you then engage the communities? What methods do you have, or what experience can you share with us?
John, please.
Yeah, I mean, I think it's completely true. Like there's no point in kind of proposing anything unless there's some kind of buy-in from communities. For me, it's a tricky one because you know, in some ways, what I'm talking about is so vast and abstract that it's sort of, there's no particular client in mind when we've been thinking about this. But what I would say is that perhaps maybe an observation that we made through conversations. So that in terms of an idea about community engagement, the exhibition that we put together was almost like a huge community outreach process. We brought in people, members of the public, we brought in planners, politicians to discuss density and to kind of, and you know, not everybody agreed with that. Not everybody, some people thought it was a, you know, not everybody also agrees on what good density or what a good level of density seems to be. Like, you know, the upper limit of density for me is probably much higher than the average Australian, for example, whereas the tolerance for density in, I imagine, Hong Kong is probably, you know, more considerable. But what we did find was that there is a sweet spot in any kind of building or kind of urban plan, which was around the sort of psychological theory about the number, or sort of social theory about the number of people who are a person is able to have meaningful relationships at any one time. And so, and that's about 30 or 40. It's about the size of a kind of small village. So in terms of an idea about engaging community, I can't give you an overall answer, but if we are to, in the context of my work, if we are to live, you know, live more closely together, it has to be done so in a fashion that sort of acknowledges that, you know, the individual cannot be kind of squashed in that process, and that we do need to kind of build cities and kind of architectures around clusters of and communities that are of a scale that are appropriate for kind of a good quality of life. And so, yeah, we've noticed that 30 or 40 figure seems to appear quite a lot in kind of new successful high density housing projects, particularly what they call Beim group or kind of community led developments through Australia and America and some parts of Asia. So yeah, I think engaging the community is about kind of building it into the process.
Thank you. Another question for Professor Doyle, actually. You mentioned about food and food sources, researching, developing your research in Hong Kong on that. But besides that, what is your next step in implementing your observations from your research exhibition and other aspects of tightness?
Well, the Hong Kong thing was very flash in the pan. So, it was a kind of think piece, a provocation. I mean, one of the things that needs to be done out of this is it needs to be quantified. So it's at the moment it's a provocation as much as anything, particularly in Australia, where so much of our landscape and our economy is built up on agriculture. The prospect of kind of eliminating the countryside is utterly radical. In fact, we produce 20 times more food than we consume. So we're a massive net exporter. So the idea of kind of leaving it fallow for particularly, for kind of reforestation or rewilding is very much sitting in the realm of not fantasy, but kind of political agitation in a way. There are some serious questions about the idea of using lights to grow food, at a time when we're already, exponentially increasing our electricity consumption, although I'd say growing food is better use of electricity than mining Bitcoin, for example. But what we're interested in doing next is I guess developing smaller scale models, really around the idea. Again, it goes back to that notion of the 30 to 40 people modules, and sort of jumping down into the architectural scale and exploring, in real terms, what an incremental improvement might be, rather than just a kind of a hypothetical scenario. So I think that's kind of interesting in terms of Anne's work as well, because as she was speaking, I was thinking, well, what is the global implications of this? So and that sort of kind of played out a little bit in statistics, but spatially, what would it mean? So whenever you kind of do these things, particularly as an architect, you have to switch between those two scales. So we've gone very, very far off in a kind of planetary scale in a sense. So it would be nice as a next step to kind of return down to the scale of architecture and sort of in all seriousness, see if there is a kind of incremental contribution.
Speaking of the global scale, I think we have time for one more question, and it's for Professor Beim. It's actually asking about, this kind of material studies and construction methods. Vernacular materials construction methods are very vernacular and quite sustainable in many places and countries. Should we learn from sort of localized cultural and historical contexts rather than doing something that's mass produced, or is there a balance that could be struck?
I think the question sort of is also an answer to the problem that is addressed. I do believe that it's both. I mean, we do have, as I mentioned before, to sort of revisit existing historical building culture, because I mean, generations before us have developed slowly but steady various different ways of building and selecting materials for certain. I mean, building in certain areas and sort of certain geographies and climate conditions. So it's, I mean, there's so much to learn from that. But I also do believe that you could say the high efficient industrialized, I mean, and I'm not just talking about sort of the industrial plants or like the manufacturing industry as such, but it's a way of thinking industry. I mean, to be industrious, to be how do you say, clever and planning your procedures and your logistics and so forth. I mean, it's a way of thinking rather than maybe it's a very high how do you say, high emission productions. But it's, I do believe that the contemporary or the present day construction industry and how we I mean the high efficiency that is sort of linked to this sort of production is also the way we have to produce in the future, simply by the fact that we have, I mean, the growing population worldwide. So in order to how do you say, reach out and provide proper housing conditions and cities in the future that are not taking up too much land, or at least building by means that are not how do you say, ruining the natural environment. I mean, that's the way to go. But I think it's a mix. It's a mix of those two ends or means.
Thank you very much. I think that's it for today. Sorry, unfortunately, I think we kind of overran a little, but really, once again, thank you for your sharing for Professor Beim and also Professor Doyle for your wonderful lectures. We hope that, you know, if we have a chance to travel again, then we can actually visit Australia and Denmark. But definitely, I think the world is getting smaller and smaller with technology, so hopefully we can have more of these kinds of discussions again in the future, online or in physical form. So thank you once again.
Well,
thank you for having me.
Yeah.
So
thank you very much. Just to say, I found it very, very interesting to listen to John Doyle's presentation as well, and I learned so much also in regard of our work. I think it's much more connected than we actually think in the first place. So thank you for that.
definitely, thank you.
And thank you to the
See you
crew.
guys again. Thank you.
Yeah.